Okay, this time we're going to look at rearranging Pythagoras because we need to rearrange it if we are trying to find the shorter sides. We know that Pythagoras' theorem is a squared plus b squared equals c squared, because what we're trying to find usually is the hypotenuse. Now, if we aren't trying to find the hypotenuse, for example in this case here, where we have the hypotenuse across from the right angle is 10 centimetres, we can label that C. Then what we're trying to find here is one of the shorter sides, and that's what we call those short sides. If we're trying to find A or B, we need to rearrange this equation. So we need to think about moving things algebraically around. So let's do our 5 steps for a start, remembering that our first step is draw the triangle, which we've done. We then need to label the sides. After that, we need to choose our rule, and it's become a lot more clear why we might need to choose a rule, whether we use the normal one or whether we choose our rearranged one. Then we're going to substitute in our numbers and solve it. Okay, same set of 5 steps, just in a different context this time, a different thing we're trying to find. Right, so we've drawn a triangle, let's label our sides. We've already done C for the hypotenuse. Let's go this time. This one is A and this one is B. So now what we're trying to find here is the B. This is the one we're trying to find on its own, not C like usual, okay? So if we have to think about our rule, we've now got to rearrange to find this one on its own, which means we need to move this A squared across to the other side of the equation, on the other side of the equal sign. We know from algebraic rearranging that if it's a positive number on here, on the other side we need to subtract it. So what we're going to be left with here is b squared equals, c squared stays the same, take away a squared this time, right? So here is our new rule if we are trying to find our b there, okay? So we have drawn our triangle, labelled our sides, we've got our rule ready to go because we've rearranged it from our normal Pythagoras' theorem, and now we need to substitute our numbers in. So simple as before, we've got b squared is what we're trying to find, we've got c, which is 10, take away our a squared, which is 7. Okay, so b squared is going to equal 10 times 10 is 100, take 7 times 7, which is 49. That means b squared is going to equal 51. And remember, to reverse this squared, we need to square root both sides. Okay, and that's going to leave us with our b value, whatever that's going to be. We'll get our calculator out in a minute. All right, so what we've got to understand is that this part here, this choosing the rule, is going to be different, but only when you are finding A or B. Now, say we actually mislabeled this or changed the label and said that this one is A and this one is B, and this is our usual rule. This time we're trying to find A on its own. That means our rule would actually have to rearrange the B section. So it would be A squared equals C squared take B squared this time, right? Very similar, but we can see the A squared and the B squared have switched around. The important thing with this is to know that if you are finding a shorter side or a side that is not the hypotenuse, your rule should start with C squared take away. There is no exceptions to that rule.